Okay, good evening, everyone. The today meeting is to continue our study in the Big Data Analytic course, going to a topic some of you may find in the beginning challenging, but really very exciting today in the direction Big Data Analytic is moving, which is the natural language processing and cognitive. Um, the agenda is a little ambitious. We are going to spend um, more time on some of the item and less in other, but it's to give you overview again of Bloomix platform and what services and how we are going to use it. Some wrap up on text analytic. You have been reading material since previous week, and you are doing a project in text analytic right now, which you should be finished by the end of this week. Then I'm going to go to the natural language processing and how this is related with the analytic of big data. I start changing the title of the course a little so everyone understands what is about this. Three-word continuous big data analytics. Sometimes they are interpreted in the technology direction. So we're talking about in this course how to do analytic on big data. Big data itself is the technology and much more about this we've been talking during these first 2 weeks of the course. And then I'm going to start to introduce you to the cognitive computing and specific computer we are going to work with and explore, let's say. Work with is very ambitious word. Actually, we are going to explore for the duration of the discourse. We cannot go in deep in any of these topics. The aim is that you, as a future professional in data science, you understand the most important thing up to now and connect them with the basic concept of analytic for big data. So that's the agenda, and of course, whoever participated have the opportunity to ask a live question. Before proceeding to what is text mining and analytic, I would like to share my screen about Bloomix. Okay, I guess the Blooming screen is there now. And introduce you, as far as I know, everyone, with one exception for the two section, have signed up for the Blooming's account and has the trial for 6 months trial option, which is the academic account. With the academic account, we have access to all the resources which are in Bloomix. And when you open, I have opened here the catalog. The number of items you see there, starting with infrastructure, application, services, is intimidating. And you should not worry about this. We are going to concentrate some only on what we can do realistically in a class of 6 credits. And some of the things we are doing in this class will be using the services in Bloomix. So Bloomix is a cloud environment in which you can mostly we are going to use what are services in these two classes. Data analytics, we are going to use services like Apache Spark, um, DashDB for analytics, and in another category of services, we are going to use Watson. This is Watson Cognitive. In your first course, most of you, whoever of you started Data 610 in Spring 16, we started using Watson Analytic tool, which is Business Analytic tool in Data 610. This is totally different for what is Watson Cognitive, and I'm going to introduce you today so you get clearer the idea. So what you should, the most important, you will learn a lot of using services in the cloud by coming here to Bluemix and doing the assignment using the tool which are available here. You should keep in mind several things. First, everyone of you entered the promo code, right? And you have different options you can explore. There is one option which says add credit card. I want to warn everyone, please do not add credit card. Very important, do not add credit card, at least for the duration you are student at UMUC. Because these are academic accounts, you sign it through the provision for the university, and as soon as you put credit card, you may be charged. Why? Because as academic user, we have several restrictions. We cannot open simultaneously more than 10 services. If you need to use more than 10, let's say 11, you have to choose which one of them to delete, and then you can continue using the benefits of Bluemix. So our accounts are valid for 10 simultaneous services, which is totally sufficient for what we are going to do in this class. Of course, for industry project, people need more. That's why, and this is the same platform, let me tell you, for which industry partners are paying services to use them. As I mean, the services are the same. Our limitation is the number of services and the storage. And for different application, you will see what is our limitation of storage. That are the only limitation of our account, but we can use anything. Of course, when I say anything, when you come here, for instance, and you see, let's say we are going to use Apache Spark at some point, okay? And you can see the plan. We are going to use this personal free, which is giving us access to Spark to Spark Executor. If an enterprise needs to do 30 Spark execution and other, they have to get quotation how much they have to pay. So you understand here, even if you put credit card and you create a service with the free, nothing is going to happen. But there are other services which are charged differently. Let's see, and this changes constantly. So I first have to open and see what it says before saying. Why? Because everything updates constantly. So for instance, when we use this, they are not charges. We are going to use this starting next week. This is in memory analytic. We are going to use this service for DashDB. The limit is not charges up to 1 gigabyte of data storage. If you need more, up to 20 gigabyte maximum, the pricing will be $50. So we don't have charges, but if you put the credit card there, automatically when you go above 1 gig, you will be charged. If you don't put credit card, you just won't be able to go above. Your service will lock you, and you will have to delete this service and open again, and it's going to work. So keep this in mind, so you can avoid any inconvenience, frustration, why is this not going, what is going on. So why I'm spending, my plan is to spend 10-15 minutes on this. Why? Because it's very important you get handle of what we are going to do. So first warning, don't get intimidated for the number of items, classes, and different services. We are going to concentrate in several of them. And you can then, in your own time, you can explore more and go above and beyond if you wish. Let me tell you, getting experience beside the main concept and hands-on doing R program, RStudio, Python, and Tableau visualization in your belt, is very important you get trained to work in the cloud. Why? Because today industry, everyone is moving to this direction. Although there are some enterprise which still feel that they have to work on premise, that means the server of the company. Everyone already understands the convenience in all the direction to go to the cloud. The convenience from point of view of price, no worry about licensing, no worry about update, no worry about maintenance, no worry about having technical personnel about anything. You just contract the service and you concentrate as an enterprise, as a company, in what are your main skills. If your main skill is medical provider, you don't have to hire a lot of people with information technology background to run your information technology infrastructure. The main concern up to now going to the service in the cloud were always been security, you know that. But now you can use private cloud. You don't have to go to this public cloud, which is Bluemix. If you run a lot of private information, you can go to the provider and you can get private server service. So just wanted to take this positively. You are going to get additional experience because this you will have to do it in your future work. Some of you are use it. Some of you are asking why Bluemix and why not another cloud. First thing, you've seen this in education. In a single class, we cannot use many different tools because for a project, we have to go all with the same tool. Otherwise, we cannot teach one student doing this in Python, other in R, third going to Spark. We cannot do this in for a single project. But you will have the opportunity in this class to be exposed in many different tools. Just all day will be in the same cloud, which is Bluemix. And we choose Bluemix for several reasons, not only because they are giving us this convenient access to the real professional cloud, not dedicated for the education. This is professional cloud for which other users are paying. We just here as educational user, not only because of this, but because I posted some links in the beginning, in the first week. You can see who are the leaders in analytics. So in this case, we are combining from the three top leaders, which are in analytics, IBM, SAS, and Microsoft. We choose one of them with good cloud, and we combine the strong leader in analytics with offering the same analytical services in the cloud. And you, at the end of the course, you will understand better what are the benefits. So, question up to here. I don't see anything in the chat. If someone has questions, please unmute yourself and ask. Otherwise, I'm going to move forward. I don't see any questions. So, supposedly, they are not questioned with this. We can move forward. Now I'm sharing the presentation, which is the PowerPoint presentation, which will be posted in the class together with the recording of this session today. Here I would like to point to your attention what we are talking about. About what is text mining and text analytics. You will find this term used indistinctly. We are not going to give one definition about what is text mining and what is text analytics. When we refer to this term, it means exactly the same. And here you will see I tried to present this very nice graphical presentation of intersection of different fields, and when they intersect, what knowledge they produce. So you can locate what you are doing right now, what you are doing next week, what you did before in data 630, what you did in 640, what you are going to do next in this class, and whatever is related with text mining. First of all, why we are paying so much attention in data 650 in text mining? Well, as a conclusion of our discussion of the previous 2 weeks, we 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 the consensus we get to the consensus that big data is 80% unstructured data, and the heavily part of this unstructured data are text and images, and that's why we are going to concentrate um, a considerable amount of time in what is text analytics in this class. Why? Because uh, text is everywhere in industry, starting with what are the maintenance records in industry, healthcare records, policy, insurance claim, and we talk about smart data. When we want to get inside for this unstructured data, which are free text, uh, written in policy, in insurance claim, we don't have a choice to get to this, to some, let's say, to some portion of this graphic. In data 630, you did data mining and you did machine learning, right? So when we intersect text mining with this field, with data mining, we are talking about text clustering and text classification, and it's exactly what you are doing right now for assignment number 1. Is this intersection text classification and text clustering, which is intersection of what is text mining with data mining. Look about this big circle here, which is statistic, which spans several areas of this. Very interesting, and keep this in mind. Now, the tendency today, you've been learning, you are listening, everything going in high tech, in industry. Everyone is talking about artificial intelligence, machine learning. Even in the Gartner hype graphic, big data is out because already satisfy the expectation. Now it's machine learning and artificial intelligence. When machine learning and artificial intelligence intersect with text mining, they are two different intersections. One is information extraction, very interesting area, and the other is natural language processing. And this is one of the areas we start um, paying attention more heavily next week. Of course, its intersection with another field, which is computational linguistics, for which we are not going to pay attention to the computational linguistics. All these parts of intersection, we are going to see them from the point of view to do analysis as a data analyst, data scientist, and mostly our interest is in the application. So other area which has to do with intersection of computational linguistics and text mining is concept extraction. And excuse me, other area is concept extraction. So this is very interesting area after exploring cognitive computing, which has to do with this area and something more. We will see later, starting from today and in the next few weeks. That is the discussion we have for week 3 to 6. I want to tell you that some students get so interested in this concept, so when they go to the 670 class, which is the last class, which is the capstone course, doing individual project, everyone in our area which is interested with the data, we have few students going in this area. They are working actually for NASA right now, project from them. So um, I would suggest I would suggest heavily that you reflect on this graphic. There are a lot of material posted in the classroom. Please review as you can at your own paces. And every time you get a chance, just return to this graphic and try to locate and get more clear view what you are doing, because what we are doing in this class is there are a lot of reading. Some of them are mandatory, but some of them are recommended, and I heavily suggest you allot time to read also the recommended reading, so you will get more benefits from this class. Every time you read, sometime you are going to get, um, I got the question. It's coming later. Where is the sentiment analysis? It's coming later. When we get to the, when you get to read several material, in order to get lost, get to this graphic. Now, to the question Danny posted, let's see if there are more. I don't want to just, where would sentimental analysis be located in this diagram? Well, sentimental analysis has to do to understand our English language, starting with this. And it's not only natural language processing, it has to do with machine learning. So it's somewhere here using different machine learning and statistical technique. So it's a subgroup here in the natural language processing, because you understand sentimental analysis is more than just understand writing English. It has to do, of course, with computational linguistics. So is right here, intersection machine learning with computational linguistics, and portion of what is sub-portion of the natural language processing. I'm sorry you cannot see where you are pointing, because that is the WebEx. I don't have the tool here in single screen actually. I will keep this suggestion in mind, Danny. I will find the techniques to do this for the next lecture. But I guess verbally you understood where it is, right? My verbal description was clear enough or not, Danny? Yes, is an intersection of computational. Oh, I cannot hear you. You are mute, I guess. Okay. Yes, is an intersection of machine learning, computational linguistics, which is this intersection gives us natural language processing, and is more specifically there. Yes. Here is the question: is the topic modeling a text classification method? Modeling is a very broad topic, and you can be modeling many different things. So I don't see how modeling can fit in this graphic. You have to refer to some specific modeling. You talk about predictive modeling, for instance. These are they are broader than this graphic. When we talk about predictive modeling, we cannot spam this in this topic if this is what you are referring. When you talk about in data analytic about the topic modeling related with data analytic, we are usually talking about modeling the data for the with the purpose what we want to get. We want to get predictive model, prescriptive, whatever it is. And in this case, this is totally outside of this graphic. This graphic is very specific when data is text. Modeling is broader. It doesn't matter what the data is. Did I answer your question? Javier? Yes, great. More questions here before proceeding forward? Okay. Here I have uh, several slides, which I'm going to go fast on them because there is a lot of related material in the class. But I very would like to point here so you understand why analytics for big data is directly related and heavily related in what we can get from text. Why? Because we concluded we are moving to the what is the value of the data, and the most value today company finds is in all these free text they have in records for health, from industry maintenance, from whatever free text. And that is the point why we are spending the time. So here I have to give you more insight of possible application so you can connect this with the area you are working now or maybe your future potential interest. I have related, for instance, biomedical field in which just analyzing the text in the biomedical literature and searching, you can extract an information relevant to creating a new cancer cure, for instance, or diagnosis, or medical diagnosis, or let's say cure plan um, for certain patient, very individual. Of course, other one is the one someone of you asked, which is the sentimental analysis. This span mostly in what is the group of business text mining application, spanning not only sentimental analysis, but we can do very heavily. Insurance company are moving to text and images analysis. Why? Because all insurance companies have all these free text claims, right? And some picture of if it's car, if it's home insurance, if it's car insurance, they receive a lot of pictures. So images and text are paramount for all these insurance companies. Not to talk about security related, which are they heavily rely on this about analyzing blogs, social media, crime detection, and of course everyone has heard about, and you wish that your at least portion of your email can be responded automatically, right? So we have to teach the computer to understand the email you receive it and respond to it. So the area of using this is not in futuristic, is today in the table, and most of the industry are interested in this topic. So that's why we are spending time on this. Question up to here? No, moving on. I'm not going to spend any time on this. Here, for your convenience, I compile all important text mining terminology, which you are doing now for the purpose of assignment number 1, which is text classification and text clustering. So what I expect is you really understand this terminology and you show me in your report that you really do. Okay? And in all the reading provided there is no problem to find all this. So the main approach in text mining is the techniques you are using now, but text mining has several, let's say, limitations. And what is the limitation of what you are doing now, the text mining? You're using all these remove two words, word frequency, word cloud, n-gram approach. All these techniques you are using in your first assignment, number 1. What is the main limitation? I would like that you heavily reflect on this. These techniques are not going you to do any insight in the context, and you understand that we as a human, we heavily rely on context. So our natural language, when we move to the natural language processing, we talk of different parts, starting with lexical analysis, which is part of speech. Then we move to something which is more, let's say, more advanced, which is the syntaxis analysis. And after you have read more or will be reading more what is possible in the classroom, you can understand that each of these, I'm just talking about the first three bullets, which is lexical, syntactic, and semantic analysis. Each of them is an area, it has been area of research, and already we have, let's say, workable implementation in this field. But still, you cannot say that we can have a computer which totally view understands our language. When I say language, don't think just in the speaking in the spoken language. You can think about the writing, because at this point, the conversion between speech and text is very successful. We are reaching every day more, let's say, more better product which can translate speech to text. So this part of the interface we are not talking about. When we talk about natural language processing, we think about that already speech is translated to text, okay? And then we start with what is the lexical, the syntactic, and the semantic analysis. And very important thing of the natural language processing is the inference. What that means? Natural language processing doesn't stop with the semantic analysis. You, it goes, the natural language is the language in which we as a human communicate. And we, when we speak and communicate, of course, we still as a human have misunderstanding. Sometimes we have to explain just because of the of how complex is the natural language. But one important characteristic in the natural language processing is the inference. What that means? That by communicating in natural language processing, in natural language, we can infer stuff. Like, let's say, I would say, could you turn the light up? Could you turn the light, please? Because that what you are understanding by this. You understand that the place we are in is getting dark, and it can be getting dark just because the end of the day is coming. But nothing of this is said, nothing of this is communicated. You totally are prepared to infer that if I'm asking, could you please turn the light, that just is because it's getting dark, and you don't need anything less. So that is very nice part of our natural language, but of course is the difficult part when we would like to make a computer to understand the synonym, the syntactic ambiguity, and what we are saying in the context. This is the most difficult part. Even we as humans sometimes have difficulty communicating in natural language to understand even in context. Why? Because context goes beyond the moment we are talking about. Context is historical concept. What that means? It goes beyond of what we are talking right now. It goes to what you have learned before. It goes to what is right in there, to what are common understanding for us as a human. So, just an example, we are not getting very abstract on this. And I want to give example because the most important thing is understand the language in the context. So if I say she's hot, there are different understanding can be on this because you don't know what I'm talking about. If what I'm talking about is in the context of a child, you will most likely imply correctly that she has fever, right? She's hot. The child is hot. If I'm talking about she's hot for someone who is walking in Washington, D.C. in end of July in the street, you understand this is the high temperature, and the high temperature in Washington, D.C., she will be hot. But I can even refer she's hot you in different contexts. It could be in the context she's sexy, right? It depends what I'm reading, and maybe the author of the book, when he's saying she's hot, is referring that she's sexy, right? So this is just simple example how the context is important in the natural language, and you understand all the challenges because our goal is to make the computer understand the natural language. Otherwise, we cannot expect that the computer can answer my emails. We cannot expect that the computer will understand the insurance claim and make, let's say, some suggestion, and so on and on and on. And without understanding the natural language, we cannot expect to get this important thing we've been talking about the first 2 weeks, to get insights for text, to get value from the text, and what is smart data. That really the business is going to get something meaningful for this data. So I borrowed this slide from IBM Watson. So you can see not only this example, why it's so difficult to understand the natural language, and even for us as a human, if you see this bullet and example, they for the first time they sound confusing. We have to get used to them to understand, for instance, how the house can burn up as it burns down, and so on and on and on. But that is the real natural language we are communicating and speaking with, and that is the language which is in the written document we want as a data analyst, and all the company wants to get value of this document in different fields. Doesn't matter in human resource, in healthcare, whatever. So it's very nice to have structured data like here in two columns, which is person or organization, in which one column is the person, the other is the organization, and we can match Welch as a person who runs General Electric, right? But if the information is not presented in this structured data, in the way it is presented today, 80% of the information is what we have to the right, which is totally unstructured data, which says that if leadership is an art, then surely Jack Welch has proven himself a master painter during his tenure at General Electric. You understand how complex is this writing unstructured text to understand exactly this, that let's say the extrapolation between leadership with art, painter, and so on and on, we do understand that actually Jack Welch at General Electric was the manager of was one of the managers. Let's put it this way. This is just to tell you how difficult it is. The advances are huge. Not to talk about different techniques, because we as a data analyst, we are not going in this realm in the solution type. We are going to use the solution. That is concern of other type of professional who have been working for many years, and already they are, let's say, useful product for natural language processing using any of these type of solution. Okay, so we are not going to do this. We are going to concentrate in what is in this slide. And as well as I asked you to reflect as many times as you can to the graphic I presented in the beginning, the next slide I want you to look very carefully and return to use as many times you can is the application. Why? Because our main concern as a data analyst is the application area and to use already built tools which are going to facilitate our analytic work to make something to extract value for any of this company or area of application, governmental, automotive, banking, you name it. So the most important I want you to see is this part. Here I'm going to go very fast in this last part because we are going to have another WebEx when we go a little bit more in deep in cognitive. But I want that you understand that we already live in a new era of computing. In the 40s, we had the tabular computing. They helped the human with certain tasks. Then is the programmable computing, which we are still in this era. The computer you're handling right now is programmed computing, and they help us with very tedious tasks like not only the job you are doing all the time, but with solving complex differential equation, modeling complex dynamic system, and you name it. Okay. The new paradigm shift is the cognitive computing, and before going to the definition, this is to the right is the graphical representation of the cognitive computer. You see by one hand is the human with the brain transparent, and the other one is a computer, obviously, to the left, which is the brain is the computer brain. Someone wants to get a take what this graphic is suggesting. I want to hear what is your reaction. What is telling you this representation? What is the most important of the cognitive computing? This is the new paradigm shift, the new computer. Anyone? Please unmute yourself if you wish. You need a little bit more to reflect? Well, I'm going to go forward and then I'm going to return. I'm going to give the main characteristic of the cognitive computing, which is mostly, let me tell you, cognitive computing is a result of how the research in artificial intelligence has progressed in the last 30, 40 years. The advance of the technology which reached a level in which we can have real implementation, what the algorithms are requiring, because we can store and of course big data. Cognitive computer is, let's say, is very closely related with what is big data, not only the big data existence, the technology for big data make possible the realization of the cognitive computer. And mostly the idea is that they refer to a system that learns, not to a system you program with a program in R, in Java, in Python. No, this is a system very similar like the human. The cognitive computer can learn, can make, let's say, reasoning, can make, can weight different findings, can make conclusion, can make suggestion. So, having said that, if I return to the previous graphic, what you would say that this graphic is telling you about cognitive computer? I see here two people already posted. Let's see what they are saying. Danny. How do you see example of advanced EM? Danny, what EM refers? EM stands for many stuff.
Dr. Course, this is Danny. So I was watching a TED Talk, and they were discussing M's, and they explained to them that the cognitive assistants, or basically virtual assistants, would be taking over a lot of our white-collar work in the future. They didn't say when. That's what that graphic relates to me, is something that's taking over our thought process and doing that type of work.
Okay, but this is what you heard in the text. Is this graphic suggesting this? Is it? I understand what you read, and we have 4 weeks to discuss this. I don't want to give my opinion right now because it's not simple. I'm not going to, because I like when you give opinion, you give justification why you think it's going to happen. But is this graphic suggesting this or not? Let's see what other people say. The computer brain is transparent and covering the whole globe. Okay. Telepathy drug transfer. Okay, let's go a little bit more and we collect more opinion. Again, I don't want to impose any opinion. You will reach the same thing we did the first 2 weeks. We get to some consensus on what big data is, smart data is. It's gonna happen with the cognitive also at some point. Maybe we require more time. So let's say the cognitive computer idea was to develop them to make sense of this 80% unstructured data, and to be very similar to the way we as a human sense, learn, infer, conclude, suggest, all these very human activity, but never the idea of constructing. I'm talking about the research and developer team. The idea was the cognitive computer is constructed by the human for the human. So when they say that, and we have to get this idea when you use some of them to do something, by the human, for the human, they try to represent this by this graphic. It's just human interact with the machine and is to be helped. So even some of the author, you know, artificial intelligence is part of this. They overlap. I'm going to present later some overlapping graphic also. What are the components, different components of cognitive computing, but this is for the next WebEx. So the idea is to not to substitute the human brain by artificial intelligence brain, but to augment human brain. So the AI for cognitive stands for augmentation. It's not for substitution. And I'm sure you will understand after we start exploring the Watson Cognitive we have in Bluemix Access for free. This was the computer which IBM, I'm sure many of you are aware, in 2011. That was a cognitive computer, not general purpose, constructed for very specific application area, and the application area is to let's say to win Jeopardy game, and the rule are a little to answer certain question in 3 minutes, and the computer restriction are the answer should come in not more than 3 minutes. I think it's not 3 minutes. I'm sorry for the confusion. It's in 3 seconds. The answer should come in 3 seconds. Second, that was the restriction to beat this computer, and 85% of the answer should be correct in order to win the game. So that was the main restriction to build this computer. Of course, IBM spent a lot of money for this, but they rely in all accumulated knowledge from university in many topics like natural language processing, deep question and answer. Why? Because you understand the nature of this type of game requires that the computer understand the natural language, understand the question, make sense of the question, and is able going deep to find the right answer. And of course, you will say, oh, in 2011 we already had Hadoop, no problem to store huge amount of data in commodity cluster and just use search for the answer. But the point is, if you are familiar with this game, even if you search all the information in the web, it's almost impossible you find the answer right away without any inference. So with simple Google search mechanism, which is the most advanced we have, you cannot get the answer in 3 seconds for the Jeopardy game. So they went with something which search information which is stored in the cognitive, but you understand it's limited. It's not all the information in the world. Like if you search internet, you can find much more information. Anyway, in a big Hadoop cluster, in supercomputer, anyway, the amount of information stored there to search is limited. So the computer must be more, let's say, advanced to make hypotheses. What that means, the hypothesis is, the first hypothesis is, oh, is this question related with history, with art, with food? Start making hypothesis, and after this hypothesis, start searching for evidence of this hypothesis, and then waiting, analyzing these evidences, and doing statistical processing to find the confidence level between the found evidences in the text stored in the computer and what the hypothesis why. And then doing this in parallel in many different directions for hundreds and thousands of different hypotheses, find the best, let's say, confidence level, and then make the suggestion, and that is the answer which Watson computer will give. So that is the main idea about Watson. There are a lot of reading in the classroom. I suggest start reading and interacting. Whatever we are going to explore with Watson is going to be in the classroom. With Watson, you are not going to do individual assignment because there is not physical time. But it's very important you get as much as possible from the discussion. Okay? One of the most important characteristics of cognitive computer that it adapts and learns. What that means? You train this computer with this data. More you train the computer, more the computer learns, and the answer is gonna be closer to the correct answer. Like we as humans learn, right? A baby still doesn't understand the same cognitive process which human being pass since being born until start understanding. Even as a old person, we are learning knowledge in the area of data analytics, in medicine, in history. We continue learning, and adapting to the reality. So that are very similar to the way we think. So I want to stop here and learn some more reflection on what The graphic means, here is one, mimic human talk process. Yes, I will say yes. This is very close, Danny. But the mimicking is not, the idea is not to substitute human, is to help human. I'm just going to give an example why is by the human, for the human, and that the idea of the cognitive is not artificial intelligence, is augmented intelligence. Simple example, Watson in healthcare. Today, you have heard that some doctor in some clinic, there is some personalized diagnosis for cancer, and it has to do with very heavy analysis in different type of analysis to the patient, related even with genomic analysis, which is going to permit to give a plan, a prescription plan, which is going to work better for this specific patient according to the type of cancer and to many other conditions which as a human body he has. So, and you understand for the doctor to do the diagnosis, that means he must read to put the diagnosis, this personalized diagnosis, at least something like 180,000 articles related with this type of patient he is treating. You understand, human being cannot do that. Well, maybe in lifespan he can do it, but not in reasonable time to do a personalized diagnosis. So then computer like Watson come to help. Watson can digest in a minute this 180,000 article, can absorb the images of the different analysis, MRI, whatever it is, can absorb different information about other blood analysis, tissue analysis, and can put them together, and based on what is written in this 180,000 article, make 3 suggestions to the doctor with confidence level, let's say, saying, with confidence level 60, this is going to work this way, and the prescription should be this way, the treatment should be this. Watson is suggesting treatment. Watson is not deciding for the doctor. Ultimately, the doctor has to review all the information, and based on what? Because the report, what's in the suggestion Watson is given, the computer to the doctor, contains based on what is this conclusion, and doctor can use his knowledge then with, so the computer took the burden from the doctor. Okay, so that's why we are talking, and we are going to talk about this much more and more. And here Elizabeth says that it relies in deep learning and neural network to process information for comparing it, teaching and data set. Yes, but this is just portion. Deep learning, deep Q&A is a portion of this. I'm just going to show what you should pay attention. These are the last 2 slides I have for today. And these slides very nicely describe the complexity of Watson. Not in general. In general, cognitive computing is more than this. This is a cognitive computing architecture trained for this specific topic, which is Jeopardy game. Okay? So if you go by single keyword search, which is very similar to Google search, the computer will match, and you start keyword hit and match. If the question is in May 1898, Portugal celebrated the 400th anniversary of his explorer's arrival in India. So first the computer has to understand the type of question. And the type of question, as a human, we immediately understand that the question is about who is the explorer. So we are looking for a name of person. And we have additional information that this happened 400 years before 1898, okay? And moreover, we are talking about that this explorer arrived in India. So this is all the information the computer have and can search in 100,000 documents uploaded in the memory of this computer in the commodity server, do this search of keyword match, and then what the computer is gonna match in this is May anniversary, and the answer is gonna be Gary. And what is this? That in May, Gary arrived in India after he celebrated his anniversary in Portugal. And this is what the computer found by simple keyword search. Now, if the algorithm which is in Watson, which is deep Q&A in parallel in different direction, is going in direction of geospatial, statistical, paraphrasing of the language, temporal reasoning. When the search is done this way, not by keyword, but in the way which is described in this diagram, then the computer, given that the anniversary was in 1898 and temporal match data will be 27 of May, in the article 27 of May 1498, where the computer, when Vasco da Gama landed in the Kapata Beach, which is in India. But here it's involved in deep Q&A and much more on this, which I'm going to explain whatever you don't grasp from the reading and the video. There are a lot of video in the next WebEx. So, question up to here. I have one more thing to say, but I can answer question if you have a question right now. Okay, keep your question after I showing you what you have to do in the discussion related with Watson. So your task now is this week to finish assignment 1, start the reading related with natural language processing, whatever is posted in the classroom, and start digging and going to the discussion. In the next few weeks, we are going to discuss the related topic with cognitive, how is this related with finding in sign and value in textual data, natural language processing, and how it can be helpful in different areas of our life. So you are going to go in Bloomix, in Watson, and you are going to explore any of these. I have a suggestion in the classroom which one, but it's not mandatory. If you would like how to proceed, I'm going to go just to one. Let's say you want to explore what is Watson, what that means, all this. Let's go back for a second because I start rushing because of the time, but it's not helpful. So, IBM spent for the first computer, which was to win Jeopardy, 3 million only for hardware, and you can imagine how many millions just for research and development of the software. Just the hardware was $3 million. So you understand with this price, who can afford this type of computer? And that was a few years ago. So today the change is not huge in the price to have access to this computer. You understand only few in this country, few companies can have the luxury to have this type of computer. Even if it's paramount, it's very important, it's going to help them to get advantage in the business. But conveniently, since you can get this general computer and train it in different area of knowledge, because that is the main point. The computer can learn in different area. Then IBM put different application, like you can see here, right now are available 12 of them for our work, and they are free. You don't have to pay anything. With some programming skill, if you work for someone, you can get really huge benefits in any area for which these Watson application are applicable. So how to explore? Let's say you're going to explore Tone Analyzer and you're going to understand how Tone Analyzer can be helpful and to reflect, oh, where I can apply that. That is the main purpose. You explore this and you try to make sense as a data analyst where this can be helpful, what I can do with this in my actual job, in any future project, or for someone else. Okay? That is the main reason to explore them. So the first thing, you go to what is view documentation. Okay? And when you go to view documentation, it's asking again to log in. I don't know if I will have to log in. But the most important thing is you read whatever you can, because it's going to tell you what is this about. It's not what you expect to be. When you read this, what is here, the different, how this was built, you will get better understanding. You have the full documentation, the API reference, view the demo. The first thing to make sense after you're reading the view is view demo. For instance, what you can get for this application. Here is uploaded, let's say, tweets, and let's say what Watson is going to tell about this tweet. Watson is working right now online. So this is the output. So what is needed from you is to explore all these applications. First, you can start with the demo, right? And the demo, you have to understand what all of this emotion means, language style, social tendency. So you will have to read a little bit of what how this was built based on what. For instance, this is online review.
Professor, can you share your screen?
Oh, I'm sorry. I'm so sorry. I'm going back. I'm so sorry.
Apologies for not telling you earlier.
So I'm talking, and no one see anything. I'm very sorry. Okay.
Well, we have good imaginations.
Oh, why you didn't tell me earlier? Okay. I'm going back to what is Watson. So this is the area I was referring. You click in services in Watson, and here are 12 different services. Your task is to explore at least a couple of them and post your reflection and interact with your colleagues. The way to deal with this, and what I said, this is just for our use, not for anyone who has access in Bloomix, and you can do a lot of stuff with a little bit more programming skill. Okay? The first thing is to view documentation. Okay? Read whatever. I went to Tone Analyzer. I decided with Tone Analyzer. You read a little about the documentation, how it was constructed, what is behind Tone Analyzer. And it's a model to monitor social media on other web data from text, like tweets, review, could be even your email, okay? And you can go here after reading what there are. You can go more in deep and read the full documentation, or just start with the demo. With the demo, let's say there are several. Let's say I'm going to. This is pre-uploaded text in this demo, and let's see what Watson is gonna say. Watson is working, and the answer is immediately in less than a second. I get the answer of Watson about the emotion in this text, which says is very sad text, okay, is tentative and social tendency openness. So you go to the text and you see if you concur with what the computer is telling you. So on and on and on. You can put your own text right here, just copy and paste and analyze, and that is the purpose, what you have to do with the different, let's say, with the different application uploaded for us, Watson application in different area. Questions?
Besides Google, are there other applications that do similar
yeah, I'm going
things? Like
back. Yes. There are 12 of them. Okay, here we go. Tone analyzer is the one I clicked. Look, and I asked you to explore at least two. There is personality and sign. Visual recognition, you can upload picture here and see what is going to tell you Watson. Okay. Natural language understanding. This is it can extract metadata from text of data you can upload there. And the good thing is, I would suggest if you can go about the demo and create actually, you can actually create the service. But before creating the service, create the service means you are going to use the API and you will have to do something, let's say. If you get time to do that, wonderful. But this is not required. Just my suggestion is you do as much as you can and focus in the applicability of all this you see, all this, and try to make sense how I can use this, because that is where all businesses are moving. They want the value of their text data, which are sitting there in different documents, and many different things can be extracted from there, and that is the main value, right? So my three preferred four are tone analyzer, personality insight, visual recognition, and natural language understanding. But you can go with whatever you want. Okay? So what I suggest is, from my point of view, from my perspective, for what I'm doing, I see more value there. I can do more stuff there. But doesn't mean that you are gonna concur with me. For you, maybe you in different area is different. So the main purpose is you see the value and the convenience to having access to a computer which costs only as a hardware $3 million, and not putting the research and development expenses, having it in the cloud and already be built in certain direction. Of course, if you are in a company which are looking, for instance, a healthcare company, they have contract with IBM, and they get a bare, let's say, cognitive Watson, and they train that the subject matter experts in that company train Watson for the subject they want. I've seen it already. They are don't remember the name of the company, but they train it Watson. Of course, that is Watson for them, and they train it that, but also in the cloud, which is not expensive. They got the Watson in the cloud. It can be private, it can be public, whatever the need of the company are. They got the Watson and they train it with cybersecurity policy. So every time and this is very relevant topic. Cybersecurity with data analytics is a hot topic, and so the combination of skill, let's say you're a data analyst and you get some insight in cyber, and you work with cyber data to help them prevent or whatever area of cybersecurity, is the topic in which there are 10 times more job and necessity that person who can do that. So many people are start training in this area. Data analysts, which as a subject matter get some insight in cybersecurity. More questions?
So, looking at your tone analyzer example, how are companies and institutions using linguistic analysis in a decision process, or how are they using that analysis to
for
affect
tone
the business
analyzer, you
problem?
mean, or for any other?
Oh, no,
So,
tone analyzer, since we were talking about it. To me, that seems very difficult to
well,
integrate
that
into
is the point.
a...
That is what we are going to do. There is no simple, I can give some insight now, but that is what we are going to do in the next few weeks. Okay? So, IBM is telling you what is this. You understand that this is a software product built on linguistic theory. Okay? And there is a huge linguistic theory which has to do how to interpret the written English with, let's see, I'm just going, since I'm not linguist, I'm going to put, you have to read, if you want, you can read. So, how to interpret all this classification that this text is reflect anger, disgust, fear, joy, sadness, is based on theory, on what is the linguistic theory of text, of English text. And of course, all this is probabilistic. You cannot expect to get from Watson the answer of mathematical formula equal to a number. This is for the programmed computer. Cognitive computer, they are giving you probabilistic answer with certain areas. So, I would say, my personal thing, for instance, I'm going to communicate with the people who work with me, with all the instructors. I would like to know how my email sounds for them, okay? I can edit my mail, pull it to Watson, and then analyze it, and I'm going to see if I want to give them positive, I want to know how my email sounds to them, and of course I have to see if it's open enough, is extroversial. You have to see the definition of all this. What is the emotional rank? What is the analytical thing? So when this application puts some number, they are saying statistically that likely this text will sound, the emotion will transmit is this way. So from point of view from communication, this is very important. Okay? This type of this tone analyzer. I personally would like to have the time to pull my mail before sending them to Watson. Okay? And you can find that is the purpose. That is what I'm saying. The most important is when you go here and explore some of these, couple of them is enough. So you get the handle, because all of these, let's say, services are built by subject matter expert in the field, which is not subject matter expert, I mean linguists. Linguists work with the software engineer to build the tone, to train the tone analyzer, okay? And subject matter expert in this application is the linguist person who knows how to interpret this, and this based on the linguistic theory. Visual recognition is totally different based on totally different information. And you can find, for instance, visual recognition is very useful for different applications. For instance, visual recognition can be telling you the time, where is the space. I can tell you, visual recognition, actually, in visual recognition, I very would like someone to compare the result of Watson and the result of the Google TensorFlow. TensorFlow is not yet cognitive computer. This is deep learning based on deep neural network, which is only portion for what Watson is, but does very good visual recognition. Okay, so compare. I can tell you, visual recognition is in any field. For instance, Department of Homeland Security, part of the identification, they, let's say they are getting some information for intelligence information, and they try to find out where exactly in the earth this place is. Okay, they get some image. They have intelligence report that the person of interest is in this place, but they don't know geographically where this place is. So they can do geospatial sample from different area on Earth, pull it to system like Watson, Visual, or Google TensorFlow, and get insight with recognition and get handle that most likely, never, these computers are not gonna give you 100%, never ever. Most likely this is there. Okay, and you are going to get the suggestion. Okay, this is regarding the visual. I don't want to tell you, I want that also you find out, because I see most of you are professional already in some area, and you can see broader and different area. Okay, just these were two examples. Any other question? More question? Yeah, that is exactly. I'm answering who is from, I don't see the name, from Davia. Yes, the question is the application area. Yes. The most important is you explore this and you can make sense where I can use that. I can tell you from previous semester, we are teaching already this for 2 consecutive semesters, and some students are coming with so brilliant idea. One of them, she said, oh, look, I work in food and drug administration. Can Watson help me? Because, and we receive constantly, let's say, project or proposal or whatever documentation. How I can check that this document coming through my disk, which I have to approve, is in line with all policy, and this is very complex problem in Food and Drug Administration. They have so many policy, and they want to find out if this document actually obeys all the policy relevant to this problem. And of course, if you are subject matter expert and you have the policy in Food and Drug Administration, you can train Watson to do that. I'm not telling that you can train any of these. You will have to get a Barry Watson to train for this type of application. But just this one, which are here, they can serve many purposes. And you can go above and beyond, not only the uploaded application here in Bluemix, but you can just hypothetically think, okay, if I can get a Barry Watson, which is not trained in anything, and I can train with this subject matter expertise, can I do that? That is valid point of discussion, and we will learn a lot. Yes, that's the purpose of the discussion.
So if I'm understanding correctly, we have to discuss where these, in what application these Watson services would be used, right?
Yeah, you just use your imagination for what you have learned and think about just hypothetically, oh, I think I can do that this way and the other way. Yes. And you just start as a data analyst, like you're going to work for a company in finances and you create the problem. This is the idea. You start brainstorming, you learn a tool, and now as a data analyst, you figure out how you can help the company you are working for. Hypothetically, maybe not the one you're working right now. It can be totally hypothetical. But always is needed some understanding of the expertise in the subject matter, domain expertise, let's put it this way. Domain, when I say domain is chemistry, physics, finance, healthcare. That is domain. Okay?
Got it. Thank you.
Welcome. I don't see more question in the chat. And also, I think that was all I have planned for today. So please read everything and don't hesitate to post your reaction. You've been doing very well by now, and I only expect going up and forward.
One more question I have.
Yes.
The algorithms that are behind, the question is algorithm that were behind the Watson application.
Yeah, you can. No, that is you have to learn everything. When you read what is in the classroom, when you read the reading, and when you watch the video posted there, you will be able to answer this question. Yes, these questions are posted there, so I know that you read the assignment reading, so you are learning. No, it's not everything you do just some coding in R or in something else. You have to read the concept, and of course you will learn what are the algorithms when you read the readings. It's in the readings and in the video. And the last two slides, after them, when you find the video, you will see the algorithm referred by the author. And you can imply some of them also. Not explicitly, you can imply them. Okay? There is machine learning, statistical analysis, inference, everything. These are in general, but you can go in more detail, okay?
Okay.
So you know the statistical part of analysis. How you think Watson calculates confidence interval. You know that part. I don't have to explain. You already almost at the end of the program, right? How confidence interval is calculated in general and how it should be in Watson, okay? That doesn't mean that this is explicitly in the reading, but you just have to infer, like we humans learn and infer from what you are reading and from what you already know. Okay? Did I answer your question?
Yeah, thank you.
Welcome. More questions? Okay, if there are not more questions, I think I'm going to stop recording. And thank you everyone for attending the WebEx. Hope it's helpful and will help you to go better over the following week and continue doing amazing job. Have a wonderful evening, everyone. Bye.